Joining me now is astronomer Mark Thompson to explain this major step towards understanding the red planet. Mark Thompson! We get a bit blasé about it, I suppose, but this, it would seem, is a tremendous leap forward.
It is, and I think space exploration is one of those things now that just happens all the while, and people, you know, we have these space missions that are, you know, every year with many space missions, and this is just another one of those, but it still is an incredible achievement. Have
we found out anything yet that we didn't know about Mars with this thing? Because the pictures have been amazing.
Yeah, they have. I mean, the landing was superb. The spacecraft that came into Mars was actually used a parachute to slow it down, first of all. Then it used rockets to slow the descent. And finally, a cable lowered the rover to the surface, and that's one we've never done that before, so it was a bit nail-biting, a bit crazy by way of trying to get to the surface, but the rover did land successfsome. It's too early to say what we've learnt yet. You know, it's going to be there for a good 2 years.
But the quality of the pictures has been
phenomenal.
Superb.
Phenomenal. There's some amazing pictures of the rocks, and of course, it's studying the rocks of Mars, like this tiny piece we've got there.
This is what I'm thrilled to have, ladies and gentlemen. You were looking at some Mars dust. Can you see that there? That is Mars. There's not much of it.
So the way we've got that is because millions of years ago, a big rock, like a meteorite, or meteor, quite why it's called a meteorite, I don't know, but... so a big rock landed on Mars, threw material off. Some of that material found its way to the Earth. We've found the meteorite in Peru, analysed it, and found that it's made in exactly the same way as the rocks the Viking lander saw when it went to Mars in the 70s. So we know that that rock definitely came from Mars because it's studying the rocks on Mars, of all the rocks on Mars. We can actually see how the atmosphere has evolved, and we can see ultimately whether life has evolved there or not.
And lots more information will come. We'll learn more about it. No green men as yet, no Martians.
Not yet. I'd be quite surprised if that actually happens.
It's been a year of great advances, but also one particular sadness in the death of Neil Armstrong, because, I mean, this was, you know, the first man to step on the moon. I remember it vividly. I remember the time it happened. I was a student at Kurt Q, and it was just incredible, this amazing guy. Did this inspire you? As his footprint on the moon?
The crazy thing is, I was actually even born when Neil Armstrong went to the moon. I was born in '73, so I didn't even see it. We had electricity. Just electricity TV. I didn't even see it, but even so, it did inspire me, and I think that's one of the great legacies of, you know, of that first step on the moon, is that it still inspires people today, so many years after the event.
It seems that he was a very special man, and a very quiet, understated man as well, and a great lecturer on science.
I think that was part of the mystery of Neil Armstrong, because he was, you know, quite a quiet chap, kept himself to himself in many ways, but he still did talk about the moon landing. But we know it did touch him, you know, in an emotional way, going to the moon and seeing the Earth, you know, just hovering there in the sky.
But he may have gone, but his footprint will last for how long on the surface?
Well, his footprint, because there's actually no weather on the moon, then it will last for millions of years. And I quite like to think that, you know, future generations may be able to go there on, you know, on history trips from school, future school children, and see that footprint still there, which, you know, it's incredible.
You see, from my point of view as a grower, the only problem with the moon and Mars is that there's nothing green there, is there? You know, you won't get any.
We have found water.
No water.
We have found water on the moon, and not as liquid, but we've found water on the moon and on Mars. There's hope for you.
OK, well, when you get your first greenhouse up, I'll come and have a look. What about the other planets that we're exploring? What are we exploring?
Well, we have been exploring planets for many years, because we've got the Alan Titchmarsh Show solar system behind me, from the sun over here. You'd probably guess all the way through, like a tesseract, but Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, a couple of smaller minor planets at the end, of course, not Pluto, not a planet anymore. But the Venera space probe went to Venus, which is just there. Hopefully that will stay on there. And when that went to Venus in the 70s, it landed on the surface of Venus, and it found that the surface temperature is about 5 times the boiling point of water. So it's incredible. There's also sulfuric acid rain. And the pressure from the atmosphere is actually so intense, it's like having a car on your head.
Oh, my
goodness. So you'd either be squashed, dissolved, or boiled. So...
maybe not number one holiday destination.
OK, so we've since been to Jupiter. This is the Galileo space probe, and it actually went, instead of going direct from the Earth all the way to Jupiter, it didn't go straight there because that would have taken far too much fuel. It actually went first towards Venus, used the gravity of Venus to speed it up, and then did a sort of slingshot effect, so it sort of flung it around, accelerating around Venus, went past an asteroid, past the Earth on a second approach, before it finally got to Jupiter.
So, jacking itself up.
Pretty much. And when it went past the asteroid belt, which is around here somewhere, it found an asteroid called Ida, which we knew existed, but actually found a small moon in orbit around Ida. And we actually found as well one of the moons of Jupiter, called Europa, is believed to have a liquid ocean underneath a solid icy crust. Yeah. So chances for life there are actually quite exciting.
And then further afield, so what about Saturn?
Further afield, Saturn, we've got the Cassini spacecraft, which went to Saturn, arrived just a few years back now. It actually had the Huygens space probe, which you can see just fixed to the side of it, which it deployed to one of the moons of Saturn called Titan, and it landed there, and it also found, I think we've got a picture of Saturn as looking back through the rings of Saturn. You can see, actually, I'm going to have to point it out to you, if you're just in the left-hand side, you can see that tiny speck. Can you see that tiny speck on the image there? That's the Earth through the rings of Saturn.
Yeah.
And it's quite stunning. But the Huygens space probe discovered that there were organic compounds of sorts, very basic organic compounds, on the surface of the moon Titan.
A lot of people would say, why do we need to know this? Why can we not just be content where we are and sort this planet out before we start going to all the others?
It's a difficult one, because why would we ever stop exploring? I think it's a deeper thing. It's not about finance. It's not about, you know, gains in any political sense. It's about exploring, and I think that's what humans want to do. And the ultimate is this thing, which is the Voyager spacecraft, and that was launched many, many years ago, and that's been trundling around the solar system. It gave us some incredible images of Uranus and Neptune, but it's been going for the last 20 or so years, and it's actually now 4 times further out of the solar system than Neptune.
Right.
So it doesn't fit on here. It probably fits if you'll duck.
Yeah.
Somewhere way over there.
Oh, right.
So 4 times further away than Neptune. It's going to pass the nearest star in about 40,000 years.
Gosh, yes. Well, we'll report back on what it finds. Thank you for paying attention. And my thanks to the man who makes it all so interesting and so much easier to understand, Mark Thompson.